Welcome to a fun and exciting ANSYS example. I have to call it fun and exciting because I know some of you at some point will be thinking this is far from fun or exciting. So the last thing that I didn't actually do yet was the bullet. It's interesting. I initially looked at it and thought this can't be that difficult to solve. So put it in and then went through the actual process, looked at the actual structure and thought, oh my god, it's an incredibly tricky one. But this is a benefit. We can use this to our advantage. So if you remember, we were looking at steel bullets hitting an aluminium plate at 500 meters per second, which, you know, is a good estimate value for the speed of a bullet. So first things first, let's get explicit in. I'm going to drag and drop my explicit dynamics. Beauty is with this, I can go relatively quick, or I can jabber on as much as I like. You can just fast forward or listen. So first things first, let's set up some materials. I'm going to right click, I'm going to go edit, or you can always double click, either way. Don't forget, this is our material state. This is where all our project materials will appear. I'm going to go engineering data source. Now in here you'll notice explicit. This is just because it has equation of state for every material within here. You've always got to remember that if you're going to do this, what I'd always recommend, if you're going to do an explicit example, always go through the materials that are already there and then just look at how these are set up, and then you know if you're doing a specialized material that you need to find the equivalent for this. So for example, let's take let's go with the material we're talking on, the aluminium 1100. So I set aluminium 1100. Now if I just gradually bring it up, we have the coefficient for Gaussian, we have the shock equation of state linear, and you can see here how this is prioritized. So you know that if you're going to do something like this for your assignment, make sure you've got these prioritized values within it. Build the specifics. You've got the Steinberg strengths. I'll get shot for pronouncing all these wrongs, but I don't know, I've just stopped caring. So I'm gonna add that in, and then I can click back on my engineering data source and we're back in business. We've got a steel, which will make us bullet out of, and we've got the aluminium. Again, a lot of students have said, would it not be lead? It would be lead if we were looking at particulars, but for this I'm not going into too much detail. What I'm interested in is setting up the true example of what's going on. So I'm going to close that. Now if you remember, in the geometry, I'm going to right click, import. Now our geometry originally is actually the bullet plate geometry. So I'm going to click open. As ever, review marker comes in, so I'm going to right click, I'm going to introduce it into design modeler, so now it becomes its own self-contained area. I need it to be because I found some of the problems that I did. I was hoping that I could get away with split surfacing. Yeah, let's go into it. I can show you where I went wrong. Okay, so there's the geometry. Let's bring it in a bit. Bullet's not the best, I appreciate it. I mean, I know a lot looked at it and went, the hell is that crap? So yeah, just bear with me with that. As ever, just need to check the geometry. Two solid bodies, perfect. Okay, so let's close that. We will be coming back to that, by the way. I'm going to go into setup, edit. So now, as ever, we're going to go straight into the setup. It's now where all the magic's going to happen. Once you're into setup, you'll notice that happened really quick. That was just me hitting pause. God bless pause button. So once you're into setup, you realise that all the geometry is in as normal. Right, so like I've been saying all the way along, make sure that when you set up a simulation, it's a bog standard poor simulation, just to get the basic bog standards running, the simple one. Okay, so I'm going to go geometry, build plate, make sure both of them are set. Right, now our target area is going to be the aluminium 1100, so I'm going to change that. Aluminium 1100. Make sure that the aluminium lever is set to flexible, and the bullet is also set to flexible. What this will allow is force to be translated, but the plate itself is the only one with the equation of state present. So we won't get deformation of the bullet. We'll get high forces passing through, but this will be pure focused on the damage of the plate itself. We're going to coordinates, connections. Now you see body interactions. Body interactions here, it just says what do you want to interact, and in our case it's everything. So we're not too bothered with connections or the global geometric systems. Right, mesh. Let's update a mesh. We're going to let ANSYS choose it. Let's see how poor it is. Oh my god, look at that. I mean, that's not so bad. You look at that. I mean, it could be worse. But you look at that tip. It could be worse. Could be worse. So, right. The next thing we need to do is, we know it's set to flexible. First things first. I'm going to set this with an fix. I'm going to fix around the edges. So I'm going to fix support. As ever, I need to be away from body. I need to be on face. I'm going to press Control. This face. Whoops, not that face. This face. This face. Spin it round. This face and lower face here. So then if I go apply, we've got all points fixed. Then what I'm going to do is go back, right click, insert, and many ways you can do this, many ways, but what I'm going to actually do is apply a velocity. Velocity on the actual body. So I'm going to go here, onto the actual body, click apply, into the component of Z, and we're going to move 500 meters per second, which is about right. The earlier bullets, as one of the students found out, actually move slightly slower, but so this is about right. So we've got as fixed point, we've got the speed that we want. Now we want is an analysis time. Number of cycles between here and there is fantastic, so we're going to go 0. Let me think. Be 3. 1, 2, 3. I think I'll try running that. I was just trying to think of the speed it's going and the distance it is, and the iteration I'm going to get in between. One thing I'd like to emphasize, right? Analysis settings. Let's scroll this up. There is a special tool going on in the background. See erosion controls. On geometric strain limits, yes. What it actually means is when the material hits its ultimate strain, what it will actually do is it will erode, it will fail, it will snap, it will give us that all-important damage, all-important debris. So, it's just for your knowledge, really. You don't need to concern yourself with that. Meshing is going to be incredibly important as we move forwards, but for that, that's fine. So I'm going to solve, and let's see what it gives us. Right, so it's finished, solved, everything's green ticked, everything's bang on, happy days. I'm going to right click, go insert, going to go I'll go with stress, go for misers. This will give me in all key elements, and it's all stuck together. I could do first principles to look at compression and tension just to see what's happening, but what I'll do is I'm going to evaluate all results. Oh, that's not good. No, that's not good at all. I don't think I've given it enough time. Look at this. Look at this. It's just about to reach strain. I haven't given it enough time. Let's shorten that down. So I've shortened down the analysis time, and then I'm going to go again. So I've rerun it again, and let's see now. Thank goodness. So an interesting one as well is we were discussing in class this deformation, and someone was saying, would it not have more debris to it? I honestly thought it would. I honestly thought that this would have been. One's brought a sampling of bullet rounds hitting an actual plate, and you'd be amazed how true this genuinely is. This area here, it looks very similar. The deformation, you can almost see the material heating up and trying to hit into debris, but the elastication of the material almost holds it together, so it becomes massively deformed. You end up with deformation across the plate exactly the same way. I was actually quite impressed, to be honest. These here, now some said before, why is there red dots? These are eroded nodes. These are nodes that have broken away from the actual sim, so these would actually fit round here. However, you look and we look at how it's breaking. We're breaking on square pieces. It's not very accurate. It's not very what I'd be looking for. So what I'll do is I'm just going to run the animation and just take a look at how it looks, because you see there it breaks through. You can see the nodes being cancelled out as it actually breaks through, which is good. Don't get me wrong, I'm not trying to take away from how good this is, but doesn't serve us much of a benefit. So let's get back, and I'm just going to go 100 frames. If we go 100 frames over 10 seconds, it looks that little bit more smoother. I say that, but that don't look too smooth neither. We can see the aluminium deforming. We've got a good behaviour coming from that aluminium. I'd be willing to bet my right bits that that aluminium structure, that we could justify quite easily. However, still not happy with that simulation. It's a good start. I like it. It is a good start. So we've got the first iteration done. Let's get back out. I'm going to go back to the model. And one thing that is really apparent here is what's needed is an impact area, a blast area. So let's spin it round. The trouble is with this is it always depends on who's modelled it. If they've modelled it right, what you'll actually end up with is something useful that you can work with, that is a benefit. Because what I mean is, if you look at where this is sitting, let's say the original datum is over here, up here. When I go to model, ANSYS will only ever see how it was originally modelled. But if somebody's done it symmetrically and they've done it using the datum as a reference point, you're in a benefit, you're in a really good state. So if I go to XY plane, now when I modelled this just for experience wise, just because I've been through it many times before where you think, God, if somebody just modelled it correctly. So I did it correct, but that was just, the only reason I was going through that is because it's such a benefit to just keep this in mind. So I'll go sketching. What I'm going to do is I need to have a particular area here where the bullet actually impacts to it. It's the impact zone. See it as an impact zone. The plate, by the way, is 10 millimeters thick. So I'll just switch my units to millimeters. And I'm going to go circle. What I'll do, because I'm in circle mode now, if I right click and then go look at, it'll just take me right there. Now this is not an exact science. This is not an exact process. What we want to do is we want to minimize the level of nodes needed and used for this particular simulation to allow us to get the most accurate that we can. And one thing that ANSYS does beautifully well is it allows you to add materials and then form a part, if you will. So what it will do is, rather than splitting a surface, this is where I went wrong, by the way, rather than splitting a surface, what I can do is I can actually create a geometry with 3 component reference points. So if you think of XY, me splitting a surface, that would just be the XY. But if I add a third piece of geometry, that adds me a third component. If I add these two together, what I've got is a geometry that's in a geometry that's represented as one geometry, if that's not too confusing, because saying that even confuses me. So what I'm going to do is I'm just going to draw this circle to a rough area of the impact zone. What we'll do for control is we'll put on a dimension, and let's see how big that is. So it's 14. Let's go. We're going to bring that down to 14 millimeters. So onto 14 millimeters. Now what we'll do is we'll bring it out spin it up. I'm going to extrude this by 10 millimeters. So I'm going to extrude. Which geometry extrusion? Yeah. Select my sketch, click apply. Sketch is selected. Now it's saying not 30 millimeters, 10. Boom. You can see there the example here. Now the beauty is with this, what we're using this for is a 3-component reference geometry that we can refine particular points to allow us to define when the mesh is going to deform in all different directions. So what I mean is this extrusion does not have to be as thick as the actual plate, because it's a component we're using for purely the meshing procedure, because these are going to become one, if you remember. So I'm going to click extrude. So we're then back into business. We've then got a positional state where everything's moving, everything's happy, everything's exactly as we need it to be. Now the issue is, at the minute, if I extend my children here, 1, 2, 3, I got 3 geometries. That is not what I was looking for. What I'm actually looking for is this plate and that geometry to become one. So it sees it as one piece, so it's fused as one piece, but it allows me this manipulation of the 3 components. So I select here, and I'm going to select here. Whoops, whoop, that nearly went wrong. There and there. So I press Control and I select both of them. I'm going to right click, form new part. Now ANSYS in its brilliance has allowed me to form a new structure based purely around these 2 components, allowing me for that impact all important area. So I'm going to close that. I mean, arguably, a student said a couple of weeks ago, if a bullet's hitting, is it wise to do symmetry on it? I mean, ideally, what we could do is we could presume that both sides will deform as much as each other. But really, I mean, he does have a point. But because this is idealistic states, because the material is equal all the way through, arguably it's almost pointless doing the whole thing. But we're going to do the whole thing for this. When we get to the end of this, I'll show you how to apply symmetry, and you can run it again to your heart's content. So let's get back into it, and let's get this solved. So I'm going to go back into my simulation setup. Update data stream has been reread. Would you like to read the upstream data? Yes, I would. Basically, you've changed stuff, what's going on, tell us what's happening, and we'll update it to your simulation. Happy days. Right, so we've got it back in, and everything's still pretty much seen as the same, apart from here. Look at that. Oh, it's like an artwork, isn't it? So what I'm going to do is right click, generate mesh. So what it does is it heightens its position there, which is fine. It's fine. So what we're going to do is we're going to prioritize the internal. We're going to prioritize this section here. Right. So under right click. Now there's a few things I've not tried yet, so let's try a new for now and let's see what happens. I'm using sizing, but I'm using body sizing. I'm going to click apply. And what we'll do is we'll drop this down to 0. We think 1, 2, 1. This would be what? Let me just try generating mesh. Oh, it didn't like me doing that. So what I'll do then is I'll go back to my face sizing. Does it want to be smaller? Right, okay. It's on an adaptive system anyway. If you look here, it's on adaptive. So I'm going to go proximity. Let me just check proximity. Proximity based structures allow me to choose different areas and allow me to play around. In quite a few of the notes, you'll notice there's quite a few differences as far as meshing procedures go. I'm just seeing if this proximity is going to allow me better. No. Let me just have a look. Stay with adaptive. Let's just have a look at adaptive again. So this runs back in and right. So I've just run it now with a new sizing. You'll notice that the sizing's all over the place. You look at all these nodes here. Now, one thing that I did change on here, if you look, I've actually changed to a proximity. This just refers to its particular area and then says whatever that proximity has been set to will make that uniformed right across. That's not really what we want. I've got face sizing on here. What I would like to do as well is I'm going to refine on these faces here as well. So I've added that and I'm going to add that in. And let's just try updating mesh on that. What this will essentially do is it should give me a very brief... Oh my good God, look at that. That is not good at all. Not good at all. Okay. Let's have a look. Right, so what I'm going to do now is I'm going to perhaps make this from 0.01 to 0.001, try and refine that a little bit. I just want to try and bring it back to something a bit more realistic. So I'll come back to my meshing. That's a lot more like it. It's what I'm after. So it gives me a bit better. But again, all this has been used. Now, what I can say is, imagine if we had a way of what we could do is say wherever the interaction's going on, just mesh that area. Ignore everything else. You could almost call it a zone, if you will. Now we can have this particular method is called an automatic methoding system. So I'm going to right click, go insert. I'm going to scroll down. Oh, sorry, missed it. I've got method here. Now what do I want to include? I want to include you, I want to include you, I want to include you. Everything in there. And I'm going to click apply. Now we can use an automatic method. It can be messy. What I want to do is say no, I want to ignore all that. I want to use a multi-zone. Wherever the three zones are going on, prioritize the closest things that are interacting together and just mesh with all your efforts to that area. So what I'll do is click update. Now what we get is more prioritizing particular areas. Now the thing that irritates me is here, if you look here, is there. It's where it's fixed, but arguably, I was speaking to somebody over the weekend actually, they were saying arguably this area here is a dead zone. It's just these are basically spring structures between the two, but this is tension, this is compression. And when you're looking, you kind of go, okay, yeah, I can go with that, I can definitely get that. So what I'm going to do with that is I am going to hit solve. What I would recommend is that you go and make a coffee or do whatever you do, just purely because I imagine this is going to take a while. So I'm going to hit solve, and here we go. Oh, is it moving? There we go. Right, what you'll have found is when it ran, you probably came up with a problem saying time step too small. So what does this actually refer to? This is actually referring to the iterations between two behaviors. Basically, as it's coming into contact, how it can talk to it doesn't talk exactly as you'd want it to. So what it does is says, well, obviously if I can't converge, it must be down to the time step, hence why it brings that back. So what I've now done is I've gone back in and I've made some modifications. If I go into here, into my main meshing, you'll notice now I've moved from proximity through to uniform. What I'm going to say is make everything a particular size all the way through. Then I've gone to my body. Under my body, I've gone 0.001, so I'm going quite tight. Now, don't forget, these element values are based in meters. Sorry, so we know that that's going to be fine as well. And beauty is, with my multis on, nothing needs to change. It'll stay the same. To make sure everything's right, I'm going to update. And, well, right click, I'm going to generate mesh. So mesh is generated. What you'll find now is that where the interactions are across the actual areas here, it's now become a lot more uniformed. It's what would be expected. It's the 8-node methodology. However, when we get into here, you'll notice that we're at a lot more tighter meshing procedure. Right, so I'm pretty confident now this will do it. Don't quote me on that, because this might go horribly wrong. So I'm just going to hit run. I'm going to hit solve and give it another whirl. So after 1 hour of solving, this is the finished product with the full meshed procedure on it. Look at this. This is what I was after. Look at that for deformation. We've got high concentrated stress areas. You can see there where the mesh has been deformed to just deflect in a true representation. This I'm actually quite pleased with. So bring this back. We should get some energy distribution. So if I just bring this up a little bit, you'll see here we should get some nice energy distribution where it almost flaps, if you will, like a ripple. So if I go, it's a phenomenal bit of work. Look at the breakdown from the nodes. You can see the nodes being tossed into a million pieces. Slow this sim down. Look at the energy distributing throughout the actual material. Full deflection, the speed in which it's going. So some of the examples I'd seen, especially in particular of the bullet damage that I'd seen, you'll notice that the deflection, well, for you who's done it, you'll notice that on your deflection, what you've actually got is almost metal that is completely flattened. However, here it's moved so quick, it's actually excited the material so much that it tears through. We've got a little bit of breaking on the debris between here and here, so that is what these nodes refer to. And then if we consider the speed of the bullet, let's go for the speed. 3, 2, 1, boom. There we go. So let's also take a look at the deflection. So I'm going to go deformation, going to go total, right click, evaluate all results. Now what we've got is a representation of this deflecting. Look at that. So you're probably wondering, why the hell is it remaining blue? This is a deflection image, don't forget. So if it's deflection, it's because the bullet is red. The bullet's the biggest thing that's moving, so that's where it can be easily lost. Let's see if we can we should be able to insert an energy plot. So we'll go stress. Let's have a look. Go stress tool. No. I'm just looking now what would be the best way. Linear stresses, middle principal maximums, intensity. So intensity stress of path. Oh no, we'll leave that. I can elaborate on this further, but I wanted to just really show you how this thing deforms, how it performs, where it actually fails. The issue is you see some of the debris that's broken here. See how it's broken off in sections, almost linearized. The one thing that we are missing from this bullet is it is not rotating. It is not rifled as a bullet would be. Arguably, in the time of the original Colt Peacemaker, I'm not sure, I could be wrong, so please correct me. I'm not sure, but I believe that they weren't rifled. So this would be a true representation of what would happen. But you look at that for damage, it's just phenomenal. Right, I'm going to click onto here, I'm going to right click, retrieve results. That's the point of ultimate penetration, when it's actually starting to break away. Interestingly, let's have a look around it. It's already breaking, so we'll move to the next pointing segment. Retrieve. Now that's over 2 separate points in space. Arguably, what we could do is look at more iterations, more steps within it. But one thing to keep in mind, that did take an hour to solve. You guys may have had a bit more of joy with that, but that wasn't the best for me. So again, if you can see here, energy dissipation on this is just phenomenal. So I come on to the next, you can see it just move the way it has. I'm really pleased with that. So also, the red markers here just show the amount of nodes that have been corroded for this to be achievable. That is something we could do a split. We could look at, let's have a look at a split surface on this. So I'm going to split, and I'm going to do, where are we going to go? Let's have a look. If I go down here, and then if I go down here and split that in 2, oh yeah, that's just rocking. You see the distribution over the actual points here. We've got energy dissipation. We've got large levels of concentration around concentrated points of, obviously, the bullet hit, but then the relation across the entire thing. We're looking at what, 9.7 to the power of 7 on the material. So, interestingly, on aluminium, it wouldn't lead to it failing. It probably allows it to be elasticated to return back. Hence the reason why it didn't do what we thought it would. So if I run this, let's just take another look. Right, I'm going to retrieve it back from the beginning. So if we go right to the beginning, retrieve results, and then let's go to the next step, retrieve results. Yeah, look at that. So see there, we're to the failure point. This is purely down to the strain limit. It hits the limit, and then it just forms this huge hole in between. So you look at that. I mean, really, you look at the segregations of these nodes here. We could even refine that. But I mean, in comparison to what we've seen from the start, it kind of does show as to why you know, a lot of people do argue what's the best way forwards to do this. The other thing is as well is this is why I really do like ANSYS for what it can do. If I zoom into the lower area, look at the distance between the bullet to the actual material. You've got this. Oh my God, there's so much shit going on right now. So if I stream to here, you've got this chord type structure. This is like, think of it as if you were running your finger through like jam, for example. As you move your finger across, you'll get concentrations where you'll get a build-up around whatever's been travelling through. Kind of like a lubrication on a cylinder of a wall. And you see here, we've got the same sort of performance. And then you've almost got, for those of you in motorsports, you've got starvation area. In lubrication regimes for piston rings to pistons, this would be a starvation area, where in essence the pressure is spin so high it's actually caused a further deformation through pure momentum of the impact. There's a lot to be said about this. Really, to verify this, to get some true results with this, we would need to do a little bit of calc. We would really, that, or unless you can get actual samples of this being damaged, yeah, we'd have to draw a line with that. So that is the bullet. I would recommend that if you do this tutorial, that you do spend, you do have some free time to let your PC just tick over, because like I said, I had to pause the recording, and that was, let me have a look, 2 hours ago, because I've already been to class. So keep that in mind. I hope you found this a benefit. If you do have any questions on that, please email me. Please come and see me. I can try and help you out with that. But anything else than that, I will see you all later.